Bismillahirrahmanirrahim. Let's start with some problems related to frames and machines. Okay, we have here a differential chain block machine in which if you look at the figure, there are basically they have placed chains. If you look at it basically, if you go here, these are our chains. These are our chains, okay, and if you look, these are our pulleys. These are our pulleys, okay. So this is a chain and pulley arrangement that they have given us over here, and some assumptions that we will say that there will be no friction at the pulleys, and there will be the mass of the pulleys is neglected. So these are the assumptions that you have to undertake before solving this machine problem, okay. So if you look at it along this in chain block machine, we have to tackle it by first considering the topmost two pulleys, okay. So we have to draw the free body diagram, but before that, if you look at it in this system here, they say to us that the magnitude of the force P is to be calculated. We have to calculate the force P, and the 800 Newton force is being lifted. It needs to be lifted, okay. So what is basically then they have said that each pulley radius, the radius of each pulley is 60 millimeters. So this tells us that the diameter of the pulley is going to be equal to 120 mm. This is very important. So since the radius is 60, so basically how are we going to calculate this is basically we will try to draw the free body diagram where the weight 800 Newton is basically being placed. So we'll try to draw the free body diagram, okay. So you have this one pulley here, and the other pulley is over here, okay, and these pulleys, if you look at it, they are basically being connected here. If you look at it, this here, and basically what we are trying to tell you here is that we will consider this system. We will consider this system. We will be considering this system only, okay. This is the system that we'll consider, and you can, including this weight, okay. So if you basically consider it, you can see that the weight is basically acting downwards here, and basically you can say the tension over here, you can see the tension is going to be upward here, 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 and here. So what we can say, there is one, this is here, 2, 3, and 4, okay. So if I say, and the weight, where is the weight acting? This is the weight, which is 800 Newton. This is how much? 800. This is 800, okay. This is 800 Newton, and okay. So whatever, this is one, if you look at it, this is one system. It goes from here, your chain along the pulleys moves here till here, till here, and it goes here. So whatever force will be here, our tension will be here, the same will be here, the same will be here, the same will be here, okay. So you can say if this is going to be what is called as let's say this is P dash, so this is also going to be, this is P dash, this will also going to be P dash, okay. So this is going to be P dash, okay, and the same, this is also going to be P dash, okay. So this is P dash, this is P dash, and this all chains are basically P dash, okay. So if you look at it by seeing this, you can say this is your diagram A, of the FBD. So what we can say is that if we apply here sigma fy is equal to 0. If we apply sigma fy equal to 0, what are we going to get? We will going to get and you know that this is the sense is going to be here. The sense is here. This sense here, this sense here, and this sense is here. Okay. So what you're going to get? You're going to get 4 times of p dash. You're going to get 4 times of p dash, and what is the weight along the negative y? Minus, you can say this is your plus y, minus 800 is equal to 0. So what will you get as a p dash? You get p dash equals to, if you divide it, 4p equals to 800. So if you want, you can just make it more simpler. You can say 4p dash is equals to 800. So what does this give us? For p dash equals to 800 divided by 4. So we get p dash is equal to 200 newtons. P dash is equals to 200 newton. So now we've got p dash. So it does tells us one thing, that this p dash basically will be the same. This p dash will be the same, which will be, if this is p dash, this is p dash, this is p dash, this is p dash. Okay. So you know, if you look this thing, now the second FBD, if you look at the FBDB, will be under consideration, will be this way. Okay, because you know where the p dash going to be acting. Okay. So if you look over here, if you draw this diagram, which one? This is calculated. Okay, this is calculated. Now we will basically be going for this diagram. If you look at it, which one? This one. If you look at this diagram very clearly, okay, from here, this diagram, okay, only if you look at it. So what does it tell you? If you look at it, that this, you have one force acting here, the other force is acting here, the other force is acting here, this here, and this here. Okay. So if you look at it here, you have basically, you can say at diagram B. Okay. You're basically drawing the FBD at, so this is your FBD. Okay. At FBDB, what is going to happen at FBDB? If you look at it, that this is your one pulley, this is your another pulley. Okay. And okay, 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 so these are your pulleys. Okay, this is your pulley and this is the other pulley. Okay, and here if you look at it, it was this force which you calculated right now. This was P dash equals to 200 Newton. Okay, and if you look at it more clearly, that this, there will be, from this diagram if you look, this is what it is, this one. Okay, so there is one cable here is acting downwards, there is another cable here, this one, then there is another cable acting this one, then there is another cable here, and then there is another one here. Okay, so, and all of them if you look at it have this is the sense, this is the sense, this is the sense, this is the sense, and this is the sense. Okay, so you can call this as per your, this is going to be P, this is P, this is P, this is P, this is P, and this is also P. So if you look at it, this one, this diagram, this is my FBDB, this one. Okay, so this is the tension P dash that we just calculated. Okay, so on this side, okay, because if you, when we consider this diagram, the P dash was in this sense, the P dash was basically coming like this. Okay, so in order to balance this, we have taken it in opposite sense. So we have got so now you apply sigma Fy. If you apply now, sigma Fy is equal to 0. If you apply sigma Fy equal to 0, you will get how much? You will get 1 2 3 4 5. You will get basically how many? You will get basically 5. There are 5 P's. Okay, but they are in negative Y because this is our positive Y. This is our positive Y. So this will be basically minus 5P and plus 200 is equal to 0. So from here you can get the, basically you can calculate your value, and it will be how much? Minus 5P equals to minus 200. So from here if you get minus and minus cancelled, so P comes out to be equals to 200 upon 5. So P comes out to be equal to 40 Newton. P comes out to be equals to 40 Newton. So P is equals to 40 Newton. So this is our P has been calculated. Now we need to calculate basically this X. Also needs to calculate this X. So how can we calculate the value of X is very important. How can we calculate X? If you look at it, for calculation of X, what can we do here is basically, if you look at the same diagram, here, okay, so you can easily predict that from here, this pulley is of 120 mm. Okay, so this distance will be 120. This pulley is of 120 mm. This is 120. This pulley is of 120 mm. This is 120, and this pulley is of 120. So there, all these distances, if you look at it, they will be of 120 mm. All these distances will be of 120 mm. Okay, if you can say this is going to be 120, this is going to be 120, this is going to be 120, and this is going to be 120. They are all of 120 mm. Okay, so you can basically calculate your moment. Okay, and this point, if you look at it here, this point is A, this point is A, so this point is A, so you can say this point will be A. This point is A. So you can say very easily summation of moments at A is equal to 0. Summation of moments at A is equals to 0. Okay, and you can say that you will take standard as this is going to be a positive moment. Okay, so how we shall calculate now? We shall calculate it by, now this is 200, and you know how much is this distance. If you look at it from the figure, this is x, this is x. Okay, so this distance is basically from here to point A is basically how much? X. Okay, so you can say very easily as, and if you look at it, this force from at point X is basically this location. Okay, at this point A. Okay, this is X, so you can say, and P dash is 200 Newton, so you can say 200 into X. It will going to be taking this cable and pulley tackle in the anti-clockwise direction. Okay, so this will be 200x. Then if you look at all the other forces we have calculated as 40 Newton, so you can very easily say minus 40 into 120. Okay, then you can again say minus this will be the first this force here that we have calculated it. Okay, this force is going to be taking your body, this force is taking the body clockwise, so minus 40 into 120, and again the other one will be minus again 40, but now if you look at it, this force is going to be 120 plus 120, it will be 240. It will be 240. What will be the this is done, what will be the third force? Okay, so it will be basically minus 40 into 360. It will be 360. And what about this force? It will be again minus 40 into, if you add 360 plus 120, it will give you 480. Okay, and all the summation of moments must be equal to 0. So here, from here, if you perform the calculation, you will get your x equals to 240 mm. This x of your is basically how much? 240 mm. So you calculated what he asked you in the question. What he asked you is this is, he's asking you, you have calculated this, you have calculated your p. Okay. Another question, what if you can see, what any mechanical advantage do you get from this type of machine? Okay, if you want to calculate, and I ask you to calculate mechanical advantage, I say calculate mechanical advantage. So mechanical advantage of this system will be equal to how much? If you look at it, it will be this is the maximum force that was basically to be lifted by this system. If you look at it, how much it was? 800. And what was the force P that the person who wants to lift are basically, if anyone, any human being is involved for lifting this heavy weight, it needs to require a load or apply a load of 40 Newton. Okay, so if I say here, so 0 and 0, okay, so 1 is a 4 and you get as 20, so 20. So your mechanical advantage comes out to be equals to, if you look at it, it will be in the ratio of 20:1. Okay, so it will be in the ratio of 20:1. This is the mechanical advantage of this system. I hope you have understood this problem because this is our first problem of frames and machines. Okay, I hope it is clearly understood. Okay, thank you very much. Jazakallah, Allah Hafiz.